Welcome to CPD Live. I'm Matthew McDonald, and it's my pleasure to be facilitating this discussion, which focuses on the ever-present problem of corrosion. Before we start, in the spirit of reconciliation, InDesign Media acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. On to today's presentation. Titled Corrosion Protection, Contributing to Sustainability, today we're going to consider how to manage and minimise corrosion and highlight the environmental benefits of doing so. At the end of this session, you should be able to explain the prevalence of corrosion in the built environment and identify its impacts in terms of costs and sustainability, identify the legislative framework surrounding corrosion and assess its effectiveness, outline the common characteristics of comprehensive, effective corrosion management strategies, identify the potential benefits, both financial and environmental, of adopting best practice in this area, and having considered all relevant factors, including location and building materials, use your professional judgment to implement an effective corrosion minimisation strategy. Today's session starts with a 40-minute discussion, followed by 20 minutes of Q&A. If you'd like to ask our panel or a particular person on the panel a question, please send a text through the Q&A field at the bottom of your screen. We have 3 speakers on our panel, and I'll be moderating. First, we have Justin Rigby, Managing Director of Remedy Asset Protection, Troy Walters, Registered Building Surveyor for TWC Group, and John Barker, a Senior Account Manager at HBT Insurance Brokers. Firstly, to you, Justin, could you first tell us a bit about Remedy Asset Protection? What does your business do and who are your clients? Considering today's topic, corrosion protection contributing to sustainability, can you talk us through some of your recent projects?
Sure, Matt. Thank you for the introduction. So Remedy Asset Protection is a consultancy aimed primarily at the corrosion industry. So whether that be steel or concrete, we have a range of experience that is mostly seen in the industrial or large infrastructure space, but we have found that we have an increasing amount of clients that come to us from commercial construction zone or even residential, high-rise residential, large body corporate structures where they have corrosion issues, and often we find that these issues are part of the construction, an issue that was initiated during the construction phase. So what we've done is we've been able to draw on those lessons from heavy industry and infrastructure and package them up into a set of systems that can benefit the construction market. That program we call Corrosion. And so what you get from Corrosion is a system whereby at the design phase, you get us to just do a high-level review of the design and see if there's any areas of increased corrosivity or potential for corrosion. At many structures, there's not, but certainly if it's coastal or something that has overshadowing or increased time of dampness due to condensation or introduced climates such as pool structures and things like that, then we nominate those as requiring greater corrosion protection and provide recommendations on how to manage that. And if those recommendations are adopted during the construction phase, we come back at, say, what you think of as framing and inspect footings and other areas of concern, and then come back again at what you think of lockup, and then a final inspection once all the additional fittings and fixtures are installed on the outside of the building, and third-party enclosures and things like that. And if we've been able to, as a team, build these improvements usually they're very minor improvements, but done at the right time, they don't cost anything. And if we're able to get these improvements through, then we can issue a certificate saying that the structure is essentially corrosion-free for the next period of time.
Okay, thanks, Justin. So now to our discussion. First, for some context, what is corrosion and how does it affect the Australian construction sector?
Okay, well, I suppose that one's for me. Corrosion is the degradation of materials. It's how materials break down. In steel, we think of red rust, but corrosion happens on any engineered material. In concrete, it's still the steel. It's the steel within the concrete that's corroding, which eventually leads to that concrete cracking and spalling. So if we're focusing on steel and concrete, corrosion is the degradation of the material. So usually a reduction of its structural properties due to corrosion pitting. And then how does it affect the construction sector? Well, it usually affects the people. It's the unforeseen thing. It's the thing that bites people. Most construction doesn't have a great corrosion issue unless you're near the coast or you have these introduced microclimates. But when it's unforeseen like that, that's when you get this aggressive corrosion, and it usually happens a couple of years after construction. So it affects the end user rather than those that were involved in the process at the start.
Troy?
It's probably also worth thinking beyond just corrosion and corrosion in structural steelwork. It is instinctively what we turn our minds to, but it does also affect other elements: metal roofing, gutters, flashings, as well as some far more expensive systems like fire hydrant and sprinkler systems. Appliances like air conditioners, hot water services, they're also subject to corrosion, particularly in those highly corrosive environments along the coastline, like Justin mentioned.
Okay, so can corrosion be completely avoided?
Not yet. We'd love to. Corrosion's been around since the dawn of time. It's been written about in ancient texts. It's nature's way of bringing everything back to its lowest energy state. So to fight corrosion, you're fighting nature. We have corrosion-resistant materials that we can use. However, they become expensive. So we can manage corrosion though. And that's the intention, is to manage it from, a 5-year horizon in highly corrosive environments, push it out to 25 years or 50 years.
Yeah. How does the problem vary according to, say, building type, location, or other factors?
Oh, well, corrosion, if we think about steel, we have everything we need for corrosion on a single piece of steel. We have anodes and we have cathodes and we have a pathway for the electrical circuit. The only thing that's missing is the moisture, which is the electrolyte, the thing that completes the corrosion circuit. So thinking of a structure, it's all about time of wetness. So whether that be humidity in the air or condensation on a south-facing surface, as well as contaminants that make that moisture more a better electrolyte. Contaminants such as sea salt. So anything within a kilometre of the coastline is usually a more corrosive area. But we also have the same problem on high-rise structures where we have a lot of time of wetness on a single face.
Okay, and what effect does it have on the sustainability of the built environment?
Well, I think corrosion speaks directly to sustainability in the sense that if you can make your structure last longer, or if it requires less maintenance because you manage corrosion effectively, there's less inputs. Okay. So now I'd like to move on to the efforts to control it. Here in Australia, what are the regulations regarding corrosion in the construction industry?
Yeah, thanks, Matt. Corrosion prevention in our built environment in Australia is largely governed by the National Construction Code, or NCC, which is divided into two volumes. Volume 2, which relates to our houses and garages, or what we refer to as Class 1 and 10 buildings, and Volume 1, that's applicable to all other buildings, being apartments, commercial, industrial, and public buildings, or Class 2 to 9 buildings, as building surveyors like to call them. Volume 2 for housing is quite a prescriptive document. It takes an approach of defining areas that are severe exposure, or those within a kilometre of breaking surf, less than 100 metres from non-breaking salt water or heavy industrial fallout. In these severe environments, houses need to be protected externally, or I should say externally exposed steel needs to be protected by either a painted system, generally a zinc primer with 2 coats of paint over the top, hot dipped galvanizing, or a lesser rate of hot dip galvanizing with 2 coats of paint over that again. Internal elements within these severe environments just needs 2 coats of a paint. It's quite a simplistic approach. If we still stay with the topic of housing, all other areas of Australia are considered to be moderate environments, and they don't need any internal protection for their steelwork. External steel can be coated with as little as 2 coats of paint, and that's deemed an appropriate level of protection for those homes. Volume 1 gets a little more complicated. Volume 1 for our apartment buildings, commercial and industrial, public buildings, those sorts of things. The National Construction Code just refers us over to the Australian Standard for Steel Structures, and it provides engineers with a purely discretional approach to corrosion protection. It simply says that they must consider the use, maintenance, and climatic conditions when they determine what is an appropriate level of corrosion prevention. It does cross-reference some other standards, but it makes quite specific reference that they are only for guidance, and it leaves a lot of that determination sitting with the structural engineers.
Okay, so do you think these regulations adequately address the problem?
Well, if I could, the table 3.4.4.7 is often referenced, and that's what Troy's referring to there about what layers of paint or galvanizing are required. But from a corrosion protection point of view, that's grossly inadequate. If you have anything more than a mild corrosive environment, that's not acceptable. In fact, if we were to apply any sort of industrial standard, you'd be looking at abrasive blast cleaning to get that steel clean before painting. That's not provided in the NCC. And I'm not saying that you need to go to an industrial level of protection for every structure, but only where you can identify areas of increased corrosivity should you really start to consider a better method of protection.
Okay. Troy?
Yeah, Justin mentioned this disconnect that exists between the National Construction Code requirements and these industrial standards. It's probably important to draw upon the fact that the NCC is based upon community expectations, and the Australian Building Codes Board have actually published a document titled Durability in Buildings, including plumbing installations. It was published in 2015, but it talks about a design life for our residential buildings being as little as 50 years, which is really quite short considering a lot of the homes that are still actively used today, albeit subject to quite a few renovations over the years. When we talk about these steel components, it reduces this expected design life to as little as 15 years. But it goes on to talk about the coatings, and these protective coatings that we become highly reliant upon are really a maintenance issue. It actually says inside that durability document that the maintenance of these coatings is not governed at all by any kind of document or legislative requirement. So we're designing buildings these days that are far more complex, that are far more difficult to build, far more difficult to renovate and repair. and have far higher demands on access in order to get to some of this steelwork. So we really have architecturally designed into our buildings this disconnect between the NCC and community expectation.
Yeah. So how does this compare to other industries?
Well, other industries know how to control corrosion. In fact, in extreme environments, we know how to control corrosion. But bringing it back a little bit to the community, I mean, along the coastline, our industrial standard for corrosion protection, the Australian Standard 2312, can effectively provide guidance on corrosion protection right there on the coast. So surf lifesaving clubs, piers, wharves, as well as residential structures on the coastline. It's being done. It's just not being specified properly to a large extent.
So why the discrepancy?
I think that...
Question?
Yeah, sorry, Troy, you go ahead.
Sorry, I was going to say that's a good question, Matt. The NCC was originally rolled out in its current format in 1996. And as I said before, it's significantly based on community expectations. Historically, we've been accustomed to painting buildings. Weatherboard houses are a classic example of that. It's always been assumed that these buildings need maintenance. However, as architectural style has progressed, as our lifestyles as homeowners have progressed, we're moving closer towards this expectation of maintenance-free structures. Although it's not significant as structural rust, failures in corrosion protection is generally only realised far beyond these builders' warranty periods. So homeowners are being left with a lot of the burden of rectification method.
Justin, do you have anything to add there?
Yeah, that's the exact experience we find, that it's this segment of the community that have a significant corrosion problem, and when it happens, it hurts everybody. It hurts the owner because that nobody else is going to pay for it, but it hurts reputations as well.
Yeah. So what are the costs, but what are the broader costs of poor corrosion management?
Well, it's probably, let me provide you an example of a project we've been involved with. It's a residential structure. It could be anywhere 1 kilometre from the coast, or let's say 1.2 kilometres from the coast. So that would be like well, let's say a couple of 100 metres from the coast. If we're thinking about the NCC, that could be St Kilda Esplanade in Melbourne, or near Taronga Zoo in Sydney. So think of a residential structure there, exterior steel portal frame, the glazing, the windows are mounted inside the steel structure, and according to the table 3.4.4.7, the steel is coated with 2 coats of alkyd enamel. In that situation, the steel starts corroding quite quickly, especially where the windows are placed within the steel, against the steel. Also where the exterior steel footings are placed next to a pool area. And so by year 5, we're asked to go out and have a look at this, and the corrosion has progressed to such a stage that near the pool, the footing has started to push the concrete away, displacing secondary materials like pool tiles. The only way to effectively treat it is to pull all the windows out, and so that you can access the steel, and to remove the corrosion would be heavy work, like abrasive blast cleaning or power tool cleaning would require ongoing maintenance. So in that situation, maybe if I can ask John, would insurance pay for that situation?
No, Justin. Insurance wouldn't pay for that remediation.
Mm. And so they wouldn't remediate the windows. Would that comply with the table 3.4.4.7, Troy?
It does, yes. You pointed out that we're more than 100 metres from still water or non-breaking surf. So, yeah, a painted finish in that application is perfectly compliant.
And John, okay, so insurance isn't going to pay to pull all the windows out and rectify the steel, but maybe where the footing is, where it's impacted the pool, would insurance pay for that?
No, I don't think any insurance policy pick up that either, Justin. So I can elaborate on that. So yeah.
Please do.
Yeah, well, I mean, the problem is, insurance companies aren't there to provide homeowners with a long-term solution to maintenance obligations, as Troy was talking about. You need to maintain your buildings, whether they're commercial or domestic. If you don't, insurers will be quick to consider denial of any claim. Your property needs to be well maintained. That's an obligation, an insurance policy obligation. Rusty roofs, gutters and pipes aren't the insurer's problem or obligation. They're not in the warranty business. You suffer water damage loss as a result of rust or corrosion. Insurers, whilst they're not likely to underwrite the cost of repair or replacement, will look at paying for resultant damage. So, pipes, drains, or gutters that have rusted or become blocked by leaves, tree roots, birds' nests, etc., they will pay for resultant water ingress issues. But the actual rust or, for example, blocked drain by tree roots, those are maintenance issues, and you need to maintain those yourself.
So essentially, the owner's kind of only covered in the event of some catastrophic failure, not this corrosion issue.
Yeah, absolutely. So, I mean, I always say as a general rule, when you look at insurance, gradually occurring causes aren't normally conducive to insurance claims. So, rot, rust, insurers will generally regard anything that's gradually occurring as unlikely to be a claim. So, wear and tear, rust, corrosion, gradual deterioration, but things that are sudden and unforeseen, catastrophic, fire, storm, impact, tree falls on your roof, that's in the insurance company's ambit, and they generally respond to those sorts of claims. So anything that is slowly occurring, particularly if it's foreseeable, is something that the insurers are unlikely to pay for.
Thank you. And maybe a question for both, but firstly for Troy, would this situation be covered by a builder's warranty insurance?
This is a slightly difficult question to answer, Justin, because builders' warranties are legislated under our state legislation. So answering this question to architects across all states becomes a bit difficult. However, there are often clauses in contracts and warranty periods for builders about defective workmanship and materials that are required to be fit for purpose. So generally speaking, if a construction technique is covered by the building code, if it's a prescriptive requirement that the builder's fulfilled, if it does fail, it's quite difficult for a homeowner to try and prove that it's unfit for purpose when the federal government in the writing of the NCC has mandated that that's what needs to be done. We are somewhat assuming when we make that statement that the materials have been installed correctly, so proper preparation of surfaces before painting, proper applications of paints in accordance with manufacturer specifications and those sorts of things. But often that level of detail is really quite hard to find when you're dealing with insurance claims or potential failures 5+ years down the track after the initial construction.
And thank you. And John, from what I understand, builder's warranty insurance is only applicable if the builder's not able to fix the problem. Is that correct?
Yeah, so absolutely. So builder's warranty cover provides owners and successive owners with up to 6 years of cover for structural defects and 2 years for non-structural defects. But it's really there for a situation where the builder's client loses deposits, the builder fails to start or finish a job, and defective work on a completed job. Bear in mind, the first thing you have to do is try to recover from the builder themselves. But if they've died or disappeared or become insolvent, that not be possible. So the real question mark is what's considered defective, and an owner has an avenue for a claim under a homeowner's warranty, but as Troy says, it's difficult for an owner to claim the work is defective, when it's meeting those code requirements you mentioned.
So at this stage, using my case study, it seems that the corrosion protections afforded this structure met the requirements of the National Construction Code. Those protections, the protective coatings, if you like, only have 2 years warranty because they're not structural. They're deemed a maintenance item, which means if they're not suitable initially, corrosion would probably not really be identified for another beyond that warranty period. And thirdly, insurance would only cover it in the event of some catastrophic unforeseen failure, which is not the definition of wear and tear or maintenance or corrosion.
Okay, so moving on. So what are the costs of poor corrosion management in terms of sustainability? Well,
poor corrosion management means that you have this unforeseen maintenance issue, and the cost of doing it right the first time is so much easier. I mean, we're thinking about structural steel. It means that during the fabrication stage, it's a piece of steel in a factory. It can be lifted up, it can be turned over, it can be prepared, it can be coated properly, and then put in place. Once it's put in place, the cost of maintenance is enormous. You've got to open up the building envelope to be able to access that steel effectively to treat the corrosion, as well as all the landscaping and secondary elements that it can impact. There's been studies worldwide that show up to 3% of our national gross domestic product, our country's annual turnover, can be saved through effectively managing corrosion. Now, that doesn't mean new technology. That means using the tools we have now, we could save 3% of our GDP.
Troy?
It's funny that you mentioned that, Justin, because as we go through these life cycles of buildings, and I mentioned earlier some of these secondary elements, appliances, air conditioners, hot water services, light fittings, they become quite an expensive maintenance item for owners to repair. A lot of the manufacturers of these appliances aren't dealing with corrosion within their appliances, at least not in these severe exposure conditions. We're talking about homes that are regularly costing well over $1 million to build, and yet for quite a nominal sum of money at a construction stage, adequate corrosion protection measures can be implemented that have huge long-term savings for owners. It's really quite ironic that we can't get owners to think about these sorts of things at a design stage.
Yeah. So given this regulatory blind spot, how can architects go beyond the legislation to ensure their work minimises corrosion?
Troy?
Yeah, so the NCC was drafted as a performance-based document. It allows us to adopt all sorts of flexible measures in order to prevent corrosion without having to rely on these prescriptive measures that, as we've discussed, are somewhat substandard. So there becomes this huge opportunity to deal with the likes of remedy asset protection and have a conversation around what is appropriate. conversations with owners regarding what their expectations are in terms of ongoing maintenance and management of these exposed elements in these corrosive environments. The conversation needs to be had early on at a design stage where owners have the ability to make informed decisions.
Yeah, and note 9 in the National Construction Code for that, the table 3.4.4.7, it actually allows, it says there's an allowance for specialist advice to be sought where the environment is beyond the scope of the document. That's not, is that prescriptive, Troy? And how would that apply?
I'll be honest, Justin, I don't believe I've ever seen anybody actively apply that note. But it does open up this giant conversation. And it circles back to what we said earlier regarding insurance and liabilities around items that meet prescriptive requirements. But it opens up that entire pathway for architects to be having conversations early on with owners about what their expectations are.
Okay, so what does risk management for corrosion actually look like?
Well, I think Troy's touched on that. It looks like an early assessment of the structure just to identify any areas of unforeseen corrosivity. I mean, particularly if you're within a kilometre of the coast, definitely. But if moving away from a kilometre from the coast, if your structure is in a built-up area, it's a high-rise structure or a high-density body corporate, or it's got introduced climates like pools or perhaps some industrial areas around that zone, that's when it would make sense for somebody like us to have a quick look at the design and the local environment and highlight any areas of increased corrosivity. And then if there is, you move forward with that. If not, it's just a very simple check.
Yeah. So Justin, Troy and John, we're getting close to Q&A, so I'll go forward to the final point on our run sheet. The final question was, what are the potential benefits of going beyond the regulations and following best practice in this area?
Well, there's definitely, look, the wider benefit is to the community and society in general. I mean, saving 3% of GDP means we're more efficient and we have better sustainability. Looking down more at an industry level, such as construction, design, specification, it helps protect our reputation for project delivery as an industry. When this thing happens, when corrosion happens, it gets people upset. So I think the direct benefit to the community is through better sustainability.
Okay. Troy?
Yeah, there are quite a few benefits, and obviously the emotional benefit is huge to homeowners. They're the ones that are left often needing to deal with this. It can be incredibly stressful, even when it's not a huge financial burden on them. And as we mentioned earlier, at a design stage, at an initial construction stage, the additional cost is somewhat negligible. It's very, very easy to deal with things when they're sitting in a warehouse and can be adequately accessed and coded and then delivered to site and installed. Retrospectively trying to mechanically remove paintwork, the consequential damage to fixed facades and claddings, landscaping, etc., becomes huge.
Yeah. John, do you have anything to add there?
Well, I think that don't rely on an insurance company to pay for what it effectively is a simple maintenance. And as Troy alluded to, the problem is I think people are getting out of the habit of maintaining. So you are required to maintain your property, and simple things like clearing gutters, reducing gating, potential problems are things that the insurers will look at the event of in the claim time. They will look at it and say, okay, you haven't done anything. That's led to a large claim. We won't be reinstating rusty gutters, and actually also we won't be paying for resultant damage because you haven't maintained your property. So it's about risk management. It's about maintenance.
Okay. Well, actually, we've got time for one more question for the Q&A, I think. So Justin, can you talk us through some examples of good corrosion management in action?
So that's, again, identifying areas of key risk early at that design stage, but then being able to implement it. Look, it's not a costly exercise. It's a small portion of the overall project. It's having a subject matter expert take a quick look at it. So that's at the top, doing that risk management point of view. Then if there are areas such as the example I provided with this exterior steel portal frame near the pool, then it's providing a better coating system than is provided in the NCC. Again, if that's planned properly, it's not overly expensive, and it's done off-site during fabrication. So that's abrasive blast cleaning with 2-pack paints rather than the single-pack paints that are recommended in the NCC. Or galvanizing is a good option too. However, along the coast or near poolside structures, galvanizing needs protection as well. So it's looking at the risk management at the design stage. It's then implementing any changes, but these changes only need to be in those localized areas. Doesn't mean the whole structure needs significant upgrade. It means we can localize these upgrades to specific zones. And then along the process is then somebody like us comes in and checks off those things have occurred, and at the end be able to make sure all corrosion related issues have been resolved.
Okay, great. Thanks, Justin. Thank you, Troy and John. Thank you, Justin. That was a great discussion. So we've got 20 minutes to go. So it's over to our audience for Q&A. As I mentioned earlier, if you'd like to ask a question of our panel or a particular person, you can nominate a particular person. Please just send it through in a text through in that Q&A field at the bottom of the screen. So first off, I've got a common question from a lot of the audience, and it's are there problems with painting galvanized steel with regard to corrosion? For example, some say either galvanizing or protective paint would suffice. Some say a hybrid system is best. However, some say a hybrid system is to be avoided. Please discuss.
Sure. So galvanizing works quite well as a corrosion protection mechanism, but like I said, coastal areas or near poolside structures, it needs to be protected. So then you need to paint it. Galvanizing can be problematic, or that's probably not the right term, but it needs special treatment to be painted properly. So if you know you're painting your galvanizing, you need to speak with the galvanizer and ask them not to apply a post-treatment they put on a passivating layer. Or if they do, you need to consider a secondary method of surface preparation. So I'm delving a little too deep into that, I suppose, but the coatings direct to steel, so no galvanizing, work very well in those environments. So we have Australian standards around that provide great guidelines and durability ranges. Is one better than the other? No. I mean, an offshore oil rig is not galvanized and then painted. It's steel with paint. But you take steel into an environment away from the coast where there's low corrosion, galvanizing will work perfectly untouched for 40 or 50 years. I probably need to give you, there's no straight answer for that one. Depends upon your environment.
Okay. Okay, I've got one here from Peter. Are there issues within Australian steel suppliers of poor graded steel, i.e. product that is more susceptible to corrosion?
We have had imported steel previously that has slightly different properties, but from a corrosion point of view, I'm not sure if there's a significant difference. It's more structural properties.
Okay. From Anita to all panelists, can you please explain what effect does corrosion have? Oh, well, no, we've already had that. Have on the sustainability of the built environment. I think we've already covered that, unless anyone has anything else to add. No. Okay, one here from Alcira. So we've talked about the regulations not being up to speed. Can you see them improving in the near future?
Yeah, thanks, Matt. In all honesty, I can't. The reality of the situation is, at the moment, and we've spoken about it, that a lot of these corrosion issues are not coming to the forefront until well after builders' warranty periods have expired and are solidly into the owner's maintenance periods. Unfortunately, a lot of legislative change is driven by industry associations and insurance companies. And given that it's not falling upon the builders' shoulders to repair, their professional associations aren't pushing for change. And given that insurance companies aren't needing to put their hands in their pockets to pay for these rectification works, they're not lobbying government for change either. So I can't see it being brought to the forefront in the immediate future, no.
Okay. Linda asks, what are the common parts of a building that are corrosive risks, apart from the structural steel already mentioned?
Troy?
Yeah, so structural steel is the obvious one. That is the one that has the largest cost of rectification, making a few assumptions around that. And it's also the one that has the largest impact on homeowners. Measures beyond that become consequential. So things like air conditioners and hot water services. I've seen split system air conditioners rust out in coastal environments inside of 24 to 48 months. They really just don't last. They become a huge cost to owners to repair. I want to say huge, as a one-off purchase. Hot water services failing for similar reasons. They're sorts of appliances that just constantly need to be replaced in those highly corrosive environments. Light fittings that fail. I've even had one builder talk to us about moving away from residential style light fittings and starting to look at marine boating equipment for light fittings, because they were the only thing that they could find that may potentially hold up to those sorts of environments.
Yeah. Okay, along similar lines, Michael says, we seem to be concentrating on steel. What about other materials, for example, aluminium and other metals?
Sure. Aluminium is often powder coated, and people don't realise that there's many different types of powder coat available. We have thermoset and thermoplastic materials, and much like paint, you could compare it to like an acrylic house paint compared to an epoxy coating. Within powder coat, there's a whole range of these different materials. So that's one issue, is putting a powder coated aluminium out in an aggressive environment that doesn't have the right protection. We also have dissimilar metals. So, putting aluminium and stainless steel and mild steel together causes a corrosion issue. And, you'll see a lot of that where different fixtures are put on the outside of the building to hold down cable trays and enclosures and things like that.
Okay. From William, what strategies would you recommend to extend the life of pre-stressed concrete structures?
Oh, okay. Pre-stressed concrete. So, I mean, essentially, concrete, we're trying to protect I presume the tendons are steel. We have GRP now as well, but we'd be looking at keeping salt out of the concrete. Also coating the concrete to make sure we call it anti-carbonation. We don't want that concrete to lose its alkalinity, which is all about passivating the steel surface so it doesn't rust. So initial concrete mix, we can have resistant concrete mixes for coatings, for corrosion, then treating the surface of the concrete so that it has a barrier to the environment, to chlorides and carbon dioxide. A few of the measures that you would use.
Okay. There's one here from Callum. So we've talked about our regulations here not being good. Are there any overseas jurisdictions who have got the regulations about right? Maybe you're not familiar with them, or
no, unfortunately I'm not. Sorry, Matt, and sorry to Callum. No, unfortunately I'm just not an expert in overseas legislation. I'm not sure what involvement Justin's had on that front, but not our area of expertise here, unfortunately. Sorry.
Yeah.
Sure. Comparing to a construction code, I'm not aware of. However, locally we have good Australian standards. Australian Standard 2312 has two parts, one for corrosion protection of steel that's exposed to the atmosphere, and the second part for galvanized steel that's exposed to the atmosphere. Additionally, on our website, we have a free download that's it's like a specification document that you can use as a reference. So that's worth a look at as well. And you can include that in any documentation you're using. And that refers back to these Australian standards. But basically, it's written the way we'd like to see the National Construction Code treat corrosion.
Okay. Another question from Sam. I'm working on a heritage building near a bay which will either have cast iron elements or aluminium elements cast to match heritage designs. These will be painted. Can you provide some guidance about this? It won't be galvanized in either design. Can you comment on cast iron?
Yes. So cast iron is very porous. I mean, the surface is undulating and has lots of surface voids and even protrusions. So if you rubbed your hand on it, it'd probably be a bit scratchy. So that's problematic for coatings. So you can still coat it. It just needs to be managed properly so that you get an effective barrier. We don't want all these micro voids in the coating that are going to just allow salt and moisture in. So I would look at, again, go to our website for that free download. That relates to steel, and it talks about stripe coating, which is effectively what you'll need on this structure, is that the coating gets brushed in rather than just and sprayed on, rather than just spray alone.
Okay. From Andrew, shop applied coatings are often damaged in transit or during erection, as are connections, particularly if not perfectly aligned. Have you got any advice about how to deal with this?
Sure. In your again, that document we have on the website talks about transport and storage. So it asks the contractor to manage that effectively. However, there's always some damage during transport and lifting, so it should be minor. If you manage your coating process effectively at the start through good specification and inspection, when it does get scratched, it's very minimal. In fact, it's probably not even got through the primer layer. So your touch up on site becomes much easier. There's a much lower level of skill required to touch it up effectively. So point is, get your specification right at the start, get your fabricators putting a good coating system on, and any impact or damage can be easily repaired.
Okay. We might have already spoken about this, but Chris wants to know recommendations for protection of reinforcing steel within coastal environments.
So if it's new concrete, you're looking at making sure the concrete mix is the best you can have. So, low water to cement ratio helps restrict the passage of chlorides later on, or sea salt. And then once you have the right concrete in place, it's providing an effective barrier between the environment and the concrete. So effective surface preparation, apply a coating that will provide a barrier. If you don't want a painted finish, there are treatments, penetrating treatments that will seal that surface up.
From Rachel, when corrosion first appears, what are the first steps to take to stop it in its tracks?
Good question. I'm glad that's how you're thinking, Rachel. It depends. Many different situations. Look, ideally, you want to go to the nth degree and get rid of that corrosion, which is essentially abrasive blast cleaning or hydrojetting. In most situations, once something's built that's not reasonable, given the noise and the size of the equipment and the space you've got to work in. So then you need to adopt a lesser method of corrosion removal, and we have different coatings that can accept that and still provide an effective barrier, but it becomes a bit more tricky. We need to assess that area of the environment and then work backwards with an effective maintenance program.
Yeah. So from Greg, in northern New South Wales on the coast, I saw a lot of corrosion of fixings in cladding boards on external walls and surfaces of houses, causing rust stains and no doubt affecting the water protection in the long term as fixings rust out. Are there standards or guidance on appropriate fixings in these situations? Does this come up as a common issue?
I might grab this one, thanks, Matt. It is starting to become more of a common issue. Proprietary claddings are a bit of a hidden devil within our building industry. The builders, or the installers, I should say, really do need to pay particular attention to the manufacturer specifications for the install. Often those manufacturer specs have some requirements around appropriate using of fixings. That might be stainless steel screws or stainless steel nails in certain applications, at least galvanized nails, and in some cases, even mild steel, assuming that the right coatings are put over the top. I'll be honest, in a lot of those occasions where we are seeing these rusting and staining of fixings in claddings, it comes from two sources: inappropriate or inadequate maintenance of the finished surface, so repainting and resealing of the external face of those materials. And secondly, inappropriate use of fixings. Builders literally just grabbing whatever nails and screws are left in the tool trailer rather than paying particular attention to what is being specified by the manufacturers.
Yeah. So a follow-up from Greg: is a structural engineer generally an expert on corrosion too? So in other words, do structural engineers generally have a good understanding of corrosion?
They should. So the legislative, chain of command, you might say, the Steel Structures Code AS 4100 has those rather high-level commentary in it regarding appropriate protection given the environment, exposure conditions and maintenance and use. So in all honesty, as building certifiers, when we're seeing documents come through from structural engineers, they certify the entire structure against that code. They should have paid attention to it. There are guidance documents that get referenced around what is appropriate under certain circumstances. How much attention do they pay to that? I'm really not sure. Are they true experts? Possibly not. Like a lot of industry professionals, they have their fingers in a lot of pies. They're dealing with a lot of different issues. Corrosion protection is not their core business, and that's where talking to somebody like Remedy Asset Protection may be worthwhile.
And
okay. Oh, yes, Justin.
Sorry, I'll just add to that bit. Thank you, Troy. The Australian Standard 4100, like you said, steel structures, it doesn't really ask the reader to stop corrosion or manage corrosion. It even says that a corrosion allowance, you can have a corrosion allowance, which just means use some thicker steel and let it rust. That is a reasonable design according to that standard.
Great. Okay, we've got about 4 minutes left. I think one or two quick more questions. I have a project in Williamstown, Melbourne, and have exposed structural steel. From our discussions with the client, they are unlikely to want to put in the work to maintain the building. How do we best prevent corrosion to the steel in our case, other than ensuring the steel will have adequate paint coatings?
I think you can't do one without the other. If it's not galvanized, you need a strong coating specification to protect that steel. That's what's going to stop it from corroding. It's the barrier to the moisture and the salt. It's what separates the steel from the environment. If the project is already commenced, and I understand that people have budgets and they get their finance based on a certain figures. So if it's already too late, jump on our website, get that free download, and that will go a long way to protecting them, excluding any unforeseen microclimates that I've been describing.
Okay. And one final question. Are there any available brochures or documents that guide best practice beyond the NCC?
Yeah, I think similar to my previous answer and one earlier, that that free download on our website will, even if you don't use it, it will help start you on the journey of where to look for additional information. Beyond that, the National Construction Code doesn't have any brochures or anything like that in relation to corrosion. It would be then getting to a more technical level and looking at the Australian standards for 2312, whether it's part 1 or part 2. Yeah.
Okay, great. That's it. So thank you, Justin, Troy and John, for your time and your invaluable insights. And thanks to everyone for your attendance and questions. Our next session will be how to help architects achieve their objectives through clever design, which is presented by Tilt. Thank you.